Hello, everyone. My name's Andrew. I'm the co-founder and CTO at Weave. Who am I and why am I talking to you? So at Weave, we build AI and ML that understands the work software engineers do. We have hundreds of companies using Weave, including Augment Code, as Vinay mentioned, with tens of thousands of engineers. So basically, we have a lot of data. And the point of this talk is it's pretty hard to know what works, right? You've all seen the hype. You've all seen this post on LinkedIn. Oh, I use like 10 agents to 400x my productivity, this type of stuff. Not real, I can tell you that. But we do have a lot of data on what is actually working at a bunch of real companies that are really making progress on this, like Augment. So we want to use that data to try to spread the best practices for what is working and help you avoid the stuff that's kind of useless. During this talk, I'll show some specific practices from 5 top teams. And the goal is that everyone in here can take at least one of these away. I'm not going to be like prescriptive or say, oh, we do this, therefore it works the best. I'll try to let the data kind of lead here. And yeah, hopefully this is useful for everyone. OK, if I had to give you like a single takeaway, a single top line, the best teams are not 100% fully autonomous. In Vinay's talk, he gave these kind of 4 levels. I think most of the best teams are in between levels 3 and level 4. So they're not fully autonomous. It's not agents writing all the code. But they are building software factories. This is a term that's kind of been in vogue in the last few months. I think the interesting thing about it is that a lot of the same principles that were used to optimize manufacturing and designing factories now sort of apply in an interesting way to software. So we'll come back to that through the talk. OK, this entire talk is framed around like what works the best for the top 1% teams. What do I mean by that? The top 1% of teams, this is measured by Weave's code output metric, which again, Vinay alluded to. Basically, this is just a normalized unit of engineering work. It's not like lines of code or like commit count that's easily gameable. It's like using AI to actually understand the work that's getting done. So we're talking about the people who are the 99th percentile of this code output metric. Cool. All right, we've set the stage. I want to show you, first of all, there's a really big difference between the top 1% of teams and kind of like the rest. Here's an instructive graph. When you look at the output per engineer, the top 1% of engineers are, there's an exponential difference here. In the startup world, VCs are very obsessed with this kind of like power law idea. I think there's a similar thing that's the data is showing in engineering outcomes, where the top 1% is just accelerating far beyond. I don't have a graph to show this, but this is accelerated over the last 6 months or so. So what I want to do is I want to walk through how the top teams are optimizing each different step of the software design lifecycle, software development lifecycle. And we'll talk through like some specific data points on each one. This is not going to be exhaustive. There's a lot of stuff that I won't touch on. I want to pick the things that are most interesting for you guys. All right, we'll start with product and design, and in particular, how organizations are designed. There's a serious trend amongst these top teams towards flatter orgs with smaller teams and higher agency ICs. And when I say higher agency, what that tends to look like is ICs are doing more of the product and design work themselves. Gregor mentioned this idea of a product engineer, which is you don't even hear as much because it's just becoming an engineer. And we're seeing exactly this on these top teams. So what does this actually look like from an organizational design perspective? A couple of instructive examples here. Telmix is one. They do telephony, very hot company right now, also quite an effective engineering team. They have 200 engineers, a single VP, and 0 engineering managers. The data shows it works well for them. I'm not sure this would work well for every single company. It's really taking the flat org design to an extreme, but I think it's an interesting data point. Now, every engineer is themselves managing a team of, the way they say it is a team of 5 agents. So in that sense, there's a lot of engineering managers, but none in the kind of people management sense. Another interesting example is Posthog. They're a Series D or so startup, and they don't really have teams bigger than 3 people. And this is very intentional. They've talked about this. The reason they don't do this is because the coordination tax as the team grows kind of like quadratically as opposed to linearly. And so they're trying to avoid that overhead. And AI has enabled this shift even more. They used to have slightly bigger teams, and they've cut it down even more. They also don't have engineering managers per se. They have team leads, which do a little bit of people management, and then they have VPs who do a lot of people management, but no engineering managers. OK, let's talk through, oh, sorry, actually one thing I want to call out here. Both of these companies have explosive headcount growth. They're hiring a lot of people. They're not replacing people with agents. They're like hiring more people and having them even more empowered. I think that's interesting because we see a lot about like recent layoffs, especially in big tech. These teams are not like doing the same. They're still scaling their humans. They're just empowering the humans even more. Okay, let's talk to the next step, writing the code. This is, of course, where most of the focus around using AI and engineering has gone. I think the interesting thing here is on the cost side. So the top teams are spending a lot more per engineer on AI tools, no doubt. They're running a lot of agents in parallel. One example, which we'll get to, is this company Spot. They're running five agents for every single engineer all the time. And they're spending accordingly. OK. But what are they actually getting for this spend? They're getting significantly more output per dollar spent than the lower tier teams. So I think this is really interesting because you might think like, the median teams are spending like half as much on AI, and therefore they're getting a lot more efficiency. No, actually, the top teams are significantly more efficient, even though their spend is like massively higher. I'm not going to today try to tell you like how to get this magical like token efficiency. There's a lot of ways to do it. It's often very org specific. But I can give a couple of examples that we've seen. One is Robinhood. So they are investing pretty hard in becoming an AI native organization. One thing they've done to this end is they've built a custom agent, fine-tuned to their own code base and requirements. I think this is interesting, not just from like we can write a blog post about we have a custom agent, but from the perspective of token efficiency. They're trying to make an agent that doesn't need to spend the same tokens over and over just to get up to speed on what goes on in Robinhood's code base in order to actually contribute to it. The other example I alluded to before is Spot, where every engineer is running 5 agents at once. So from a factory perspective, if we think about a software factory, this is all about improving the throughput, getting more widgets off the line every single hour. But what comes next? You can't just put all this straight into prod. You need to actually review the code. So what do we see for these top teams about how they're reviewing the code? First of all, they're getting way fewer reviews. This is the number of review cycles. And we see that there's like way fewer for these top teams. Does this mean that they are just YOLOing code into production all the time? No. They use AI to kind of fix this, to bridge this gap. Now, Vinay kind of alluded to this as well. This is not that humans are completely out of the loop or just one person has to own the entire product. I think a lot of the review shifts much earlier in the process. I can say what we do at Weave, for example. We almost never, human reviews are entirely opt-in. Instead, we review specs. And so if an engineer is working on a particularly thorny problem, they'll write a spec. They'll send it to whoever they think would be able to give good feedback, and they'll review that. The idea is like it's much easier to review 300 lines of Markdown than 3,000 lines of code in the end. And when you're reviewing the code, you're just trying to understand what the Markdown said anyway. Let's continue along the process here. So we've talked through reviewing the code. What about QA? We don't have as much data on this one, at least in terms of how people are running the QA process. But we do have data on the results. And the results are pretty interesting. Even as the output rises, the bug rates are staying flat. So you can see the orange bar here is the kind of number of bugs introduced per output unit. And then the blue bar here is the weekly output. So even as output is increasing, the bug rate is not increasing very much. This flies in the face of what you might think. Oh, if you're shipping code this much faster, you must be putting a lot more bugs into production. And the answer is that's not actually what's happening. OK, so how do people do this? Again, I think Vinay's talk had some good tips on how they do it specifically. I'll call out another interesting story here, which is AI. This is a relatively early stage company building AI for patent litigators. They have 5 laptops that are 24/7 running and testing their app. They're the equivalent of what human QA testers would be doing, except they're not humans. They're laptops running Codex 5.5 with computer use. I think this is one way to do it. There's a lot of other tips. Again, this is pretty org specific. But shifting a lot of the work that would have been done by humans or wouldn't be done by humans because it's too costly or take too long over to agents can lead to some like asymmetric outcomes in terms of the quality of the software being shipped. The last step in the process is actually deploying the code. And this one I think is interesting because it kind of matches the like pre-AI world. There was, from in the 2010s, a whole push toward like CI/CD, continuous deployments, optimizing for DORA metrics, the number of deploys, and there's a pretty similar pattern going on here, where the top teams are deploying significantly more often than other teams. This one is interesting. I don't think you want the tail to wag the dog on this. You don't want to optimize for how often you're deploying. The way I think about this is if you deploy 10 features in one deploy once a day, it's basically the same as deploying the 10 features in 10 deploys. And so if you just optimize for that, you won't actually get any kind of increase in like feature delivery. But it's an interesting pattern. This applies not just on a per engineer basis, but also on a company basis. That's what this is showing here. Even for very large companies, the deploy rate is increasing. OK, so this is a kind of high-level overview of the data that we're seeing across the entire SDLC about how the best teams are using AI to be more effective. What's the takeaway here, though? Like, what should you take home from this? Well, hopefully you get like one interesting practice from what we said here. But really the question is, how do you continue to improve? Looking at LinkedIn for hype is not one of them. There's a lot of misaligned incentives, wouldn't recommend it. Really what you need to do is you need to understand where you're at now and then continuously measure that as you continue to iterate, understand what's working, double down on the things that are working, and avoid the things that aren't. Again, I think the Augment code example is an inspiring example here. And what you need to actually understand if you're improving is data. So that's all. Thanks, everyone.